Hello, ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today we're going to be going over mass-to-mass conversions. Okay, these a lot of times are a little bit simpler than the two-step ones, but the big problem is that these require 3 different steps. On the bright side, the 3 steps are consistently the same. Now, the final way of using stoichiometry to convert things is called a mass-to-mass calculation or conversion. Now that's where you're going from grams of something to grams of something else. And it is the most useful type of stoichiometric calculation. Because remember, we don't know moles of things. Like you don't look at a container and says, oh, you have 5 moles of, iron carbonate or iron 2 carbonate in this. Instead, it says you have 400 grams of iron 2 carbonate. So we always use mass when we're doing calculations anyway. So that means that it's probably going to be more useful to use mass-to-mass calculations when we're doing stoichiometry. So no matter what, though, when you do mass-to-mass calculations, you're always going to be converting from grams of something to grams of something else. And that means you're always going to start by converting from grams to moles using the molar mass, no matter what. Next, because now you have moles, you're going to be using the mole ratio. And then finally, you're going to be going backwards, and you're going to be going from moles back to grams using the molar mass of your new substance. So why is a mass-to-mass calculation so useful? Well, the first thing is we always weigh things in grams, right? We've weighed hundreds of things probably in lab already, and every time we used a scale that measured things in grams. There is no direct way of converting from grams to grams, okay? If we're looking at Mole Island, I know this sounds a little bit weird again because there's no like gram to gram calculation on Mole Island, but in reality, you can't just directly convert from grams to grams of something. That's not really possible because the grams of, iron 2 carbonate and how many particles they have is going to be different than the amount of particles that are in, something else like 200 grams of calcium sulfate. And remember, moles is always the common unit. So that means that I can use a mole ratio once I have things in moles as a method of getting back to the unit I would like to be in, which is grams. And so what I do is I call this mass-to-mass conversion the bridge method, and it's like building a bridge. So that's going to be my analogy, and remember, you don't have to memorize this, but the bridge method is given to you on your exams. So first step, convert from grams to moles of your given substance. That's like going up, grams to moles. Next, got to cross the bridge, mole ratio. Use your mole ratio. And then finally, moles to grams. Simple as that. Okay, so it's up, over, across. In case you forgot to go from grams to moles, you divide by molar mass. To go from moles to grams, you multiply by molar mass. So let's take a look at this. Pretend I have this balanced equation. How many grams of H2O would be produced from burning 5.4 grams of C5H12 in excess oxygen? Always the same, right? What am I given? 5.4 grams of this. What do I want to know? How many grams of this? Now, anytime you see grams and grams, that's a 3-step process. So you need a conversion factor box that can hold 3 different conversion factors. What's my mole ratio between those two? 6:1. Nice and easy. Start with what you're given, 5.4 grams of C5H12. First step, divide by molar mass. All right, what's the molar mass of this thing? Add up the molar mass of C5H12 from your periodic table, you get 72. Next step, use the mole ratio. Boom, 6:1. Last step, I want to go back to this. I want to get to H2O. I need to know the molar mass of that. I multiply by the molar mass. What's the molar mass of H2O? 18. Now notice, everything cancels, right? Grams of this cancels with grams of this. Moles of this, moles of this, moles of this, moles of that. So everything cancels and I'm given just grams of H2O. You still want to write everything down though because you want to be consistent and not make any mistakes. So in your calculator, do 5.4 divided by 72, multiplied by 6, multiplied by 18, and you get about 8.1 grams of H2O. So if I start with 5.4 grams of this stuff and I burn it, I get 8.1 grams of this. Why is that useful to me? I can weigh this. Why is this useful to me? I can also weigh this. And I know I'm supposed to get 8.1 grams. So if I don't get 8.1 grams, either, something went wrong, or I didn't weigh this very accurately when I was trying to weigh it. Next up, pretend you have a balanced equation like this. How many grams of Fe2O3 would be produced from burning 10 grams of Fe in excess oxygen? Good. Let's follow the same directions. 10.0 grams. What do I want to know? I want to know how many grams of iron 2 oxide I'm making, or sorry, iron 3 oxide I'm making. All right, let's take a look. It's grams to grams, so I know that's a three-step process. What's my mole ratio between these two? It's a 2 to 4, so 2 over 4, or 1 to 2, if you want to simplify it. Plug in what you know. 10 grams of iron. Good. What is the molar mass of iron? I need to divide by molar mass for my first step. 55.85. What is my mole ratio? I'm going to do 2 over 4, but you could have also done 1 over 2. Same answer. And then I need to add this up. What is iron 3 oxide's molar mass? Because third step, I need to multiply by molar mass. Add it up, you get about 159.7 grams. So what does that mean? Everything cancels. Yay! 10 grams divided by 55.85 times 2 divided by 4 times 159.7. What does that get in your calculator? About 14.3 grams. And again, that's how you solve any gram-to-gram question, okay? It's 3 steps. It's called the bridge method. It's a lot easier than the 2-step ones, I think. And that's because you always do the same thing. Divide by molar mass, mole ratio, multiply by molar mass, always, and it's always in the same order. All right, so if you have any questions, let me know.